Now, let's take a look at actually how we're going to construct a confidence interval. And remember, a confidence interval has this general form: your point estimate plus your margin of error. In this margin of error calculation, we'll know the point estimate, we'll know the standard deviation of the statistic, right? The sampling distribution. It's the critical value that confuses students many times. But that's going to be based off of what level of confidence you want to have with your confidence interval. And so it's called the z-critical value. This is the first way we're going to do this. And so notice that you're going to have your sampling distribution, and I want to cut off 95%. Where are 95% of the samples, the means of the samples, right? Of the distribution, right? Where are 95% of those values? And then you have these cutoff points, which we've done before. We've used the normal distribution in StatCrunch, the normal calculator, or you can use the ArtStat, which we've done this already. You just didn't realize we were answering some of these critical value questions prior. And so suppose we wanted a critical value of 95%, right? A confidence interval. What you do is you draw a picture like this of your normal distribution, and then we're looking at, if 95% is the center piece, you have 2.5%, right, on both sides. And that alpha, again, is represents that percent, what we called earlier, this means 10% of the time the interval produced would fail, right? The percent of time that our interval will fail to contain the population parameter. And so looking at this, sorry about that, we'll come through it. We know right now that the z-critical is 1.96. Let me show you how that comes to be. Using StatCrunch here, stat calculators normal. And in this case here, we would want the between and that critical z. So we're looking at 0 and 1. And so what you're going to put here is 0.95 in between. And so you'll see I get the negative 1.96 to 1.96. So that's how we calculate that critical value. And then we use the positive one, the right tail we use to do that. Another way we could have done that was just using that, and then since there's 0.025 on the right tail here, then you get your 1.96 again. You can see you have that value. That's the other way. But that's where these values come from. I'll show you ArtStat on another calculation later, how to do that. But you should know how to do that process in the ArtStat already. Now, we do give you these three here. These are the most common critical values for z-criticals, depending on your confidence level. Your alpha, of course, is the percent of intervals that will not contain your population parameter. And here's your critical values here that are assigned with them. We use these so often you end up memorizing what they are. You don't have to do these calculations, but you'll get some values that you have to calculate these. And so just as a practice, here are some questions. What's the critical value for these different confidence intervals here? And so I'll show you one, but I'll let you try this rest of them. Now, in each of these, as you have a 98% confidence level, that means your alpha is 0.02. Here, your alpha is 0.20, because 20%. Your alpha here is 0.005, okay? And your alpha here is 0.10, because we're looking at the turning those to decimals. Let's just do the 98% one. Your alpha is 0.02. I'm going to use the ArtStat to do that. And so again, the ArtStat, you're going to use the normal distribution calculator. There it is here. And we're looking in the right tail. 90, what did we say here? 98% is in the middle. And so what we care for is we're going to find the percentile or quantile. And so you could do the two-tailed one and then put 98 in between. And then you can see you get your critical value here, 2.326 or 2.33. That's the way to do that. If you're going to use a right tail, the upper tail, then the percent is 1 because it's alpha divided by 2. You can see again, you get your 2.33 again within here. So make sure you know how to do that with that. Because we're going to end up using this skill of calculating critical values to go ahead and do some examples here.